Welcome to a video tutorial on tools for graphing in Minitab Express. Today's lesson is on scatterplots. In order to do a scatterplot, you're going to need data. And we will be taking our data from the pulse rates dataset in Minitab Express. This is a view of the data with the descriptions of each of the indicators. This was downloaded from the Minitab website and placed into a spreadsheet. This is a publicly available spreadsheet. This data was then copied and placed into Minitab. As for where to copy the spreadsheet or to have information about what the indicators actually mean in the spreadsheet, please look at the video description. In our lesson today, we're doing scatterplots. So what we're going to do is go to Graphs and select Scatterplot. If you have a PC, the menus will be very similar. This particular tutorial was done on a Mac. The menus are similar. Minitab Express has identical functionality between PCs and Macs. Right, I'm going to select Scatterplots. And for the first example, I'm going to do a simple scatterplot. In order to make a scatterplot, you need to measure variables that have measures. It asks you to provide a y variable and an x variable. So we have to think about what is the meaning of y and what is the meaning of x, especially if it's been a while since you've been in a math or a statistics course. Oftentimes those are confused. In mathematics, the x variable is oftentimes referred to as the input or the independent variable. In statistics and in data science and artificial intelligence, they have alternate names for it, but it still means the same thing. The x variable is oftentimes called the predictor variable or the explanatory variable. They have the same meaning. The y variable in mathematics is oftentimes referred to as the dependent variable or that output. Now in statistics or in data science or in artificial intelligence, oftentimes they will refer to the y variable as the outcome variable or that response variable. Again, these mean the same thing. So really what you're trying to figure out is, in the case of the x variable, this represents something that is influencing the outcome, in this case the y variable. One way of thinking of it, if there is a causal relationship, the x is representing that cause, and the result of that cause, the effect, is reflected in the y variable. What we're going to do is look at the relationship between height and weight of the participants in this study. And what we want to think about is which one makes more sense to put in the y variable category and which one makes more sense to put in the x variable category. If a person's height influences their weight, that would indicate that the height should go in x and the weight should go in y. And more often than not, a person's height will influence their weight. Short people tend to weigh less, tall people tend to weigh more. So the causal relationship, when we think about it, is when we look at that x variable, we're going to put in height here for x, and for the y variable, we're going to put weight. And let's see when we do a scatter plot what occurs. Click OK. And again, we want to move the spreadsheet portion down in Minitab Express so that we can see. So you notice this x-axis, this horizontal axis, is where height is being plotted, anywhere from 60 inches all the way up to 76 inches. One of the things is, because we can edit these labels, I think even would be better to do that right now, because height by itself is not particularly helpful, but height in inches is definitely much more descriptive. Likewise, we can also, this y-axis, this vertical axis, represents the person's weight in relation to their height. So right now this is measuring weight. So again, the weight was being measured in pounds, not kilograms. Let's put LBS, that's the abbreviation per pounds. And a scatter plot of weight versus height. Maybe we leave the title as it is. When they talk about something versus something else, the Whatever is mentioned first is that output or that outcome. After versus represents input or what is we think is influencing the weight, whatever is influencing the outcome. So a typical template is this is where the y variable is represented and the versus, and then this is whatever the x is, variable is standing for. And that is why Minitab put it exactly this way. Height is the x, weight is the y. As with other graphs, we can customize these settings. So by clicking on the graph, you'll notice that this graph elements comes up. And you can again adjust show or not show the title, show or not show a subtitle, add a footnote or not have a footnote. The axis labels are what we just have here. If you take them off, they disappear. You can also choose to keep one or the other or both. Tick labels have to do with the scaling, so if you uncheck this, there is no scaling on this scatter plot. And again, you can also choose to either eliminate one or the other. It is really good practice to have labels on both the axes and the tick marks, so you definitely want to keep those. The data display, when you click on that, will just connect the lines. Sometimes it is meaningful to connect lines, sometimes it is not. In this situation, it is definitely not. So we'll leave it as a scatter plot. Data labels, that will do is put every one of those output values that you see here, every one of those y values next to the dot. You can also arrange above, below, left, or right, meaning changing its position relative to that plotted point. Now in some cases, I just put it back to above. In some cases, when a graph is not very dense, oftentimes it's helpful to see that. When you have a scatter plot like this where there's a lot of dots, sometimes it's too busy and it's hard to follow. So I will simply unclick it right now. It's a regression fit. That is something we will definitely be spending the latter part of the semester discussing what does it mean to do a regression fit of dots. Does it appear to have a linear relationship or other types of relationship? So what we can do is click on regression plot. It will draw a straight line through the dots. There are certain statistics that will then tell you whether this is a good fit or not, if it's an appropriate fit. And you can choose linear, quadratic, or cubic. Each has its purpose. In this course, we'll be studying whether a line is a good fit for it. Other statistics courses you take may also have quadratic regression or cubic regression also. Right now I'm just going to turn it off. Grid lines provide grid lines both in the x direction and the y direction, just for easier identification of points. And lastly, you can also include reference lines on both the x-axis and the y-axis. If you choose to do that, suppose I wanted to put a horizontal line through 160 as some sort of benchmark, I could do that. And then I push space, and that will then draw in that particular reference line. To erase a reference line, I would simply backspace over it and push space, and that will do away with the reference line. Similarly, you can also do vertical lines along the x-axis. Suppose I wanted to make a mark at 70. I could do that, and you will see over here that a vertical line was drawn at the x-axis where x is 70. Which is when the height is 70 inches. Perhaps you wanted to make a distinction between people who are above 70 inches of height versus those who are not. And again, to erase any of these lines, you would simply backspace, press the space bar to clear out the reference line. So that's a little bit about how the customizations to a scatter plot work. But let's also take a look at, you can also do scatter plots within groups. What you may notice is that what we have done is we have done the relationship between the height and weight of everyone who participated in the study. The study did consist of male and female participants. So let's see if we can actually take a look and see if we can learn anything additional by adding this extra lens on the scatter plot. So we're going to do it one more time. We're going to go to graphs, and we're going to do scatter plot again. with one minor modification. Rather than doing a simple scatter plot, we're going to do it with groups. And what it's going to do is it's going to ask us the y variable and the x variable. Again, the x is what we're thinking. If we're thinking of a causal relationship, x is the cause, and then y would be the effect that was influenced by whatever happened with x. We think that height influences weight, so what we're going to do is put height in for x and weight in for y. The one thing that we're going to then do also is we're going to group by gender. And let's see what that does to the plot. So you're going to have, oops, I did not want to do that because that's not where I want to put it. So I made a slight error, easy to fix. Let's say you make an error like I just did. Simply backspace. That will eliminate. We want to repopulate the x variable with height. Now we're back at group variable, making sure that cursor is in that group variable box. And what we want to do is group by gender. And we're going to highlight and then click the right arrow in the grouping variable to do a grouping by gender. At this point, we're going to click OK and to see what type of graph it is. One thing you will notice is that when you do grouping, it will also create a category over here on the upper right corner, which gives you a color code or a key to distinguish how the different groups are. So I believe it did a blue square for female, and I believe it did a red square for male. One thing that you will notice is that the female participants seem to be more on the left side of the graph, while the male participants tend to be more on the right side of the graph. And part of that reason might be is when we look at it, females are overall shorter than males. So as we're looking at this, one of the things that come up is we do still see a possible linear relationship, meaning that we could imagine drawing a straight line through using that regression fit. But what happens here is you'll have, when you do two groups, it will do a regression fit for each individual group. So that's one of the changes that occur when you do a grouping. It'll do a regression line per group. But the question is a straight line a good fit for the data? That is something we'll explore later in this class. But one of the things, I'm going to turn it off for the moment. But we do notice this, one of the trends that you can notice from Scatterplot, and that's one of the reasons why we do Scatterplots, visually it appears as height increases, so does the weight of the participant. Taller people tend to be heavier, and the graph does show that. Also, what we all from this additional grouping, we also learn that the heights of females who participated in this study tended to be overall shorter, and that they also overall weighed less. Meanwhile, the men tended to be taller, and they also overall tended to weigh more. This is one of the ways you can use scatterplots to gain insights into the patterns in the data. And that concludes this particular video lesson. I hope you found this helpful.